Hello friends, so today we are solving this problem, length of longest V-shaped diagonal segment. So we are given a 2D integer matrix grid of size n cross n where each element is either 0 or 1 or 2. Only these three types of elements will be there. So a V-shaped diagonal segment is defined as that the segment starts with 1 and subsequently elements follow the infinite sequence of 2 0 2 0. It's repeating like that, but we are starting with the 1. And the one thing is here that start along a diagonal direction. Okay, so we have 4 diagonal in a matrix, right? So it should start according to that, right? And the continuous sequence in the same diagonal direction. So one more thing is we can get along to any direction according to the diagonal, but we can make at most one clockwise 90-degree turn to another diagonal direction. So we can visualize like this in a better way. For example, you can see, let's say this is the 1. Okay, so our start point would be 1 only. Now there are 4 directions. It can go to in this way. This is also a diagonal direction. This is diagonal direction. This is also a diagonal direction. And this is also a diagonal direction. So at any one, we have to look for a series. For example, this is the 1, right? So this could be our start point. Now from this one, this is a diagonal direction, we are getting 2. Then in this diagonal direction, we take one right direction, so 0, then 2. So this, we are finding this 2 0 2 0 series, right? This is what we have to do. For example, if we could have a start from here 1, then diagonal direction we are getting 2. Then here in the same direction also we are getting 0, right? So either we can, whenever we are reaching at any one, okay, at that cell we have to look for the diagonal direction, that hey, is there any 2 0 2 0 series? For example, if we go to this direction, we don't have 2 itself, so this cannot be a traversal direction for us. In this way we are getting 2, yes it can be, but thereafter we are getting only of the length 2 here. Now we will check here, there we are getting 1 to 2 and then 2 to 0, so 3 length is here. So if we go here 1 to 2, now we are taking one rotation, okay, 190-degree clockwise direction rotation, because at most 1 is allowed. So from 1 to 2 we reached, and then we took a 90-degree turn in clockwise direction. So we got 1, then 2, 2 to 0, and then another 2. So you can see here that 4 direction is the maximum out of all of them. Okay, so we have to check for all the diagonal direction, and then at most one right turn we can take. We cannot, right turn means the clockwise only. We cannot take like this, that 1 2 and like this we cannot take, right? So you can take one more example here. For example, you can see here, so first of all in the cell we have to reach at any one, like this is the 1. Now we will go to, so how many diagonal direction? This is the diagonal direction. This also could be a diagonal direction, though if we are going out of bound, then it's not our problem. Out of the array we cannot go, right? So here only this possibility, but anyway we are getting 2 here. Now we have to get from here onwards 2 0 2 0. So for example, 1 to 2 we reached in the diagonal direction. Now from this 2 we are getting next 0, right? So that is also valid. Now we can either take right, can we take this direction? No, because this is anti-clockwise, even though this is the next one is 2 only, because we are looking for 2 0 2 0 2 0. So we, from here we got 2, then 2 to 0, but 0 to 2, this also could be a valid sequence, but because this is an anti-clockwise like this, so that is not allowed. So 1 to 2, 2 to 0. Now here we cannot move because this is not 2, so here only this is 0 to 2. Okay, now we can move in this direction also, because this is a clockwise, or we can go straight. So basically what we have to do is either we can go along the direction that we got along the diagonal, or we can take at most one clockwise turn. This is what we have to do. Now whenever a 1 reaching, we have to find the maximum length of such series 2 0 2 0 2 0, with either on the straight of along to direction, or at most one clockwise direction move. So this is what we have to do. Now there could be multiple such one, and out of them we have to find the longest one. So you can see here at most one clockwise 90-degree turn, either 0 or 1. Okay, so this is what we have to do. So See here, return the length of the longest V-shaped diagonal element segment. If no valid segment exists, return 0. So there could be multiple, but we have to find the longest one. Okay, so this is what we have to do. Now the next thing is how to do that. Okay, so first of all, let me clarify a few things here, that whenever we are so there are 4 possible directions, right, as you guys know. So these 4 possible direction is like at, let's say we are at any ij, right? If we are at any ij cell, then there could be the 4 possible moves for the direction. So one is like 1 and 1, right? So if we add 1 and 1 to I and j, we will get the next value. So for example, if we are here, if we add 1 and 1, we will reach here at this diagonal element. So 1 and 1 we would be adding, then we will reach this diagonal. If we do like this, so what will happen? Here row is decreasing, so we can make -1 here, and the column is increasing, so we can have 1 here, right? So that is also a possibility. Now we can have this direction also. So what that direction is doing? That direction is doing the row is increasing, so we are increasing it by 1, but the column is decreasing, so we will take here -1, right? And similarly this is also a direction, opposite direction, right? So whatever we are heading it, we are decreasing directly, right? So it would be -1 and -1 for both of them, either row or column, both of them are decreasing. So these 4 possibility at any ij would be the diagonal one. Okay, now one more thing is like whatever direction we are going, we have to look for the right turn as well, right? So for example, when we are going along this, right, so this would be 1 series, right? Every time we are increasing x and y both, right? So this would be 1. So if we want to find that, if only the right turn would be possible when column is decreasing and row is still increasing, right? So 1 and -1, right? 1 and -1 series would be the right turn for 1 series. So you can visualize it like this. So these would be the our four possibility of all the diagonal values, right? 1 1 1 -1. So you can see here on 0 we have put 1 and 1, right? Like for this 1, this 1 and 1, if we are adding ij, I plus 1 j plus 1 would be coming here, right? So if we look, this is 0, so next one, so 0 plus 1, this guy would be the right direction of it. For example, we are going 0, see, we are going +1 +1, right? Now if we want to make a clockwise move, this would look like this. So this here what is happening, row is increasing but column is decreasing. So if we are changing to the right turn, then this would be the new diagonal. Similarly, if we are at this diagonal, we can make the next one, right? So on any ith direction, if what we do is like we can see here, on any ith value, okay, if on any ith value, okay, we want to take a right turn, this would be like I plus 1, okay, I plus 1 would be the right direction diagonal of it, okay. And we can also make %4. Why I am making %4, I'll tell you, because on last value, so for example, if we are going along this direction, then +1 would be this guy, right? So this is 0, then 0 plus 1, so this guy would be the right turn for it. If we are at 1, then this guy would be the right turn for it, okay. And if we are at this diagonal, then next guy would be the right turn. So basically on any ith diagonal, if we want to take a clockwise 90-degree move, that would be sitting on the next value, I plus 1th value, right? And we are making this %4 because at this direction, for example, at third, if we are at here, this -1 and 1, if we are along this diagonal, what would be the right turn diagonal? This would be like 3 plus 1, so it would be 4%, so that it would become 0, right? So this guy would be the 0. So for this diagonal, if we want to take a right turn, this guy would be the new diagonal after making the right turn. So this is what I want to say here. So we will have this kind of array. Now we write the code for it. So what is our criteria here is like whenever we are finding any one Okay, at that time we would be calling a method which would be find us the maximum value. Now at this one we would have all the four possibilities along the diagonals which are we are giving here. Okay, so now we will call our method for all those directions, right? All these four directions, this direction, this, right? So now we have to find this 2020 series. Okay, and at most one clockwise turn would be allowed. Now this would be like there would be at any point we would have two possibility that this is the 2, the next target should be 0, right? Then if it is 0, the next target should be 2. Now we also have to keep track one boolean variable which would be taking that had we taken a right turn or not, because only one right turn is allowed, one clockwise turn is allowed. So for that one boolean variable we can take that, and whenever we have to find the both possibility, because we don't know, we can go straight towards the diagonal or we have to take one move and then there might be leading for a better solution. So we have to find the biggest length. So what we will do here is we can do the memoization recursion approach here. So we will write the code together so that it will make a better understanding. Okay, so let's say we are writing our code here. Some initial introduction of these values. So what we are doing here is, first of all, these are the diagonals that we just explained, all those four diagonals, right? And these m and n and this grid. Why I'm taking this? Because these would be required globally, and we will write a utility methods, so we cannot pass these many parameters. So that is why I'm doing. So here I would be creating one more called dp here, and this dp would be for memoization, right? And this memoization is of 4 length, you can say 4D array. Now some of you might have wondered that why this 4D arrays. So 4D arrays, like we have this grid, right? So ij, so for every ij we have 4 directions, right? And in those 4 directions also we have either the turn or not a turn. So ij, this first you can consider for I, second for j, and this third for those 4 directions. So here we have these 4 directions, right? And then the last one would be the this thing. This would be for the turn. So it would look like, if I write here this dp would be look like this. So this dp would be new int, and this would be whatever is the size of row, and this would be the size of column, and this would be the size of those directions. So we have 4 diagonals, and this would be of size 2 because we can either turn or not turn. Okay, so that is why we are taking this memoization array of the 4D array, right? So it's simple, don't have to be confused here. Now we are writing this DFS method. So you can see here x and y are the coordinate on which we are calling this DFS, and this direction is the dir, the current diagonal, right? For example, if we are going along this diagonal, then this would be the value. So this 0 would be anchoring for this 1 1. When we are adding, like here, if we are going in this way, we are adding every time I 1 1 for x and y. So in that case, this 0 would be direction, and for all of them, like 0 1 2 and 3, so one of these values would be, so this is direction, and this is the turn boolean variable. This boolean is basically, if we have taken turn, this would be false, otherwise it would be true till the time. For example, let's say we are starting from here, right? So when we are reaching this 2, till that time turn is still true. But now if we start turning in this way, then turn would become false, right? Because we have taken turn and only one turn is required. So whenever we are taking any turn, this turn value would become false. Now this is next. This value is nothing but like we have to find the 2020 series. So if let's say we are starting, then initially we need 2. The next time it would be needed 0. So this is the next value in the 2020 series. This will anchor, and this dp is the nothing but that memoization dp. Now what we are doing is, let's say we are calling this method at any xy. Okay, so first of all we are taking the new directions. Now you can see here this dir. This dir telling us that on which diagonal we are currently. Okay, so this dir and this value 0. So just like here. So if we are, let's say if dir equal to 1, then these values we are adding into x and y. If dri equal to 0, then these value we are adding into x and y. So that this is what we are doing. So this d, you can see here we created global variable this d, having these diagonals, right? So we are taking them only. So now these are our new coordinates. So first of all, once we get the new coordinate, obviously we have to check all the null checks that they should not go out of the boundaries. So if it is any one of them is less than 0 or greater than the max values required, right? So all those checks we have to put here. So let me complete the code, otherwise it will take much time. So you can see here that these are the boundary check. If they are going out of boundary, or this value itself is not equal to next, right? Then also we have to return 0, because this next is expected. So if the new coordinate doesn't have those next value, then we have to anyway stop it. At that point it would be returning 0. Here, after doing this check, what we are doing is we are looking for this turn index, okay, because based upon this turn is boolean variable, right? And we took that we have the four dimensional array, right? So if turn index if turn is true, means if it is still not taken, then we are taking 1, otherwise we are taking 0. So turn index we have 1. Now what we are checking here is we already filled everything as -1, right, in this array, right? So we will check that if it is not -1, that means we are returning whatever value is already pre-calculated. Otherwise what we are doing, we are calling this DFS on this variable int max, you can consider. Then we are calling these new coordinates, right? We created these new coordinates nx, n and y, and this direction, and turn is still then, and then we are making 2 minus next. Why this 2 minus next? Because if we have already occurred 2, right, then only we are calling, then 2 minus next would be make it 0, because next would be 0. So 2, if it is starting with 2, then next would be the 0, and then next would be 2. So for that reason we are taking 2 minus next. So here we are parking this value into this max variable. Now we are also looking for the turn, that if turn is true, that means we can take a turn, right? Because we have to look all the possibilities, we just cannot go in any greed way. So if turn is still not taken, means if turn is true, then what we can do is we are taking the turn value as well. So whatever max we got here with the straight value, we are passing this max in the math.max, and we are calling this dfx. So see here, we are calling on nx, ny, and we are changing this direction, because direction is only possible for the this thing clockwise way, and we already discussed here. See here, we discussed that on any diagonal, if we want to take the clockwise turn, then this would be the new diagonal, I plus 1% 4. So same thing I am doing here. So whatever is the direction plus 1% 4. So this would be my new diagonal, and I am making false, because turn we are taking this time. So we are taking false, and we are making this 2 minus next, means whatever is already occurred, we are taking the next series in 2020 way. Now here we are checking the straight value, and here we are checking for the max value inside when we take the turn. Okay, now this max would be having the maximum value after going the straight or going to the clockwise turn possibility, right? So whatever value max has, we are parking this value in this DP array, you can say memoization array. So we are storing it, and we are returning this max plus 1 value, right? So this is simple memoization DFS. Okay, now this DFS we are using in our main method. Okay, so this is our main method. So you can see here, these are the global variable which we already created. Now we are filling them. So m, row and columns and grid, and this is our this memoization array, right? So we created this, and here in this what we are doing is we are filling initially everything as -1 in this DP array. You can see here we are filling this -1 value for every cell. Now what we are doing is, this is our resultant variable. Now you can see we are traversing, and whenever we are finding a grid equal to 1, then only the direction has to be checked, right? So see here, we are going into all the 4 directions, right? We have 0, 1, 2, 3. You can see here we have 0, 1, 2, 3. So 3 possible diagonals. So we are looking for all those 4 possibilities. Now we are calling this method, this DFS method, for whatever ij we found 1, we are calling this ij and direction for all the 4 diagonal direction, and we are initially passing this as true, and because our series has to start with the 2, so 2 0 2 0, so that is why we are taking this as 2. So we are getting whatever is the maximum value for getting for this one, and this rest would be basically having the maximum value out of all those possibilities. Okay, and we are making this plus 1 because why we are making this plus 1, because we are starting from point 1 and then we are getting the length of this series from this DFS, right? So we are making this plus 1. So finally this rest would be having the maximum value which we are returning. Okay, so let me execute this code. So I'm running this code. So let me try to submit it. Okay, so I'm submitting it. Yeah, so it is 85.53 faster. So what is the time complexity here? The time complexity here is the m and n are the row and column length of it, right? So it would be O of m into n, so you can say quadratic. And space complexity also, we are taking the extra space, so space complexity also m into n. So thank you for watching this video, and if you guys have any concern, please make a comment over there. I will definitely come back to it. Thank you.